guys, now we're going to talk about liquids and evaporation, vaporization, boiling, and what controls these events. You all understand the concept of water boiling, but why does water boil at 100 degrees Celsius? Let's first of all remind ourselves that the particles are super far apart. They move in constant rapid straight line motion if this is this gaseous container. And their collisions are elastic. And remember, their average kinetic energy is related to their temperature. So the higher the temperature, if you increase temperature, you increase kinetic energy. They're going to move faster, and you saw that on the PhET video that we did. Now, what about liquids? Well, liquid molecules are much closer together. Liquid molecules slide over each other. But the liquid, because the molecules can slide over each other, they will conform to the sides of the container. So if you have a large container, if you had a smaller container, the liquid will conform to the sides of the container. So what determines what liquids stay in the liquid? Because we know that liquids have the ability to evaporate. Okay? So the fancy term for evaporation or boiling is vaporization. And that term makes a lot of sense, vaporization. And when we talk about vaporization, we can be talking about evaporation, or we're going to be talking about boiling. So first of all, in this video, I want to talk about evaporation. So picture a beaker of water, and picture these molecules of the liquid in this container sliding over each other, and I'm not going to draw them all. Now, a liquid molecule on the surface of that liquid will be able to evaporate if it has enough kinetic energy to, quote, break free or leave the surface of the liquid. So liquids can vaporize if they have sufficient kinetic energy and if they're near the surface of the liquid, that molecule can vaporize. So let's think about this in terms of a class. Let's say I had a classroom full of students, and these are my test grades. Let's say I had a 92, a 92, a 91, an 89, a 77, a 75, and a 72. So clearly the students either really understood the work or they really did not. Now, what is the average of this class? Well, we have 1, 2, 3, 4, 5, 6, 7 students. And if we add these all up and take the average of this class, the class average is an 84. Now, according to my theory of evaporation, the molecules with the highest kinetic energy can leave. Okay, so let's say my two students with the highest grade can leave. I say, all right, if you got above a 91, you don't need to be in here for this explanation. You can leave the class. So off these two go. Shunk, shunk, they left the class. Now what's my new class average? Well, it makes sense that if the higher grade people leave, the class average is going to fall. So now let's see what my class average is. Oh, my class average just dropped to an 80.8. Why? Because the higher grade people left. So it makes sense with my liquid, as the higher kinetic energy molecules leave, what's going to happen to the average kinetic energy of my liquid and the average temperature? The average kinetic energy will decrease, and thus the average temperature would decrease. So evaporation has a cooling effect. Evaporation has a cooling effect. Okay, so let's keep up with this. What if I'm teaching and I say to my students, okay, anyone who got above an 85 doesn't need to be here. So my higher grade students left, and then I was left with those with the lower kinetic energy or the lower grade. Now what's my new average going to be? You can see my average now has dropped significantly all the way down to approximately a 75. Just like over here with my molecules of water, the more high energy, kinetic energy ones that leave, the lower the average is for those left behind. So that's why evaporation has a cooling effect. If this was your arm, let's see, 4 fingers and a thumb. Oh wow, that's an amazing arm. Kind of looks like, let's just not worry about it. Maybe it looks like a foot or a leg. But anyway, here's my arm, and I just got out of, okay, it looks more like a leg. So let's go with it being a leg. I just got out of the pool. These are not the measles. And I have all these molecules of water on my skin. Now, what happens when you get out of the pool and it's a slightly breezy day? You get chilled, right? Because evaporation has a cooling effect. Why is that? Well, in order for these molecules to leave your skin, they need sufficient kinetic energy to vaporize. If they get sufficient kinetic energy to vaporize, they can leave your skin. And then your skin is dry and you get a little bit of a chill. So why did you cool down? Well, where are they getting that energy from to leave? They're getting it from the temperature in your skin. So they're converting heat energy to kinetic energy, and then they're leaving. And that's why you get the chills when something evaporates. Let's talk about that again. You have a molecule on your arm. This molecule right here wants to leave. It takes some of the heat energy from your arm, converts it to kinetic energy, and now it has enough kinetic energy to leave. Now think about this. If hundreds of molecules are doing this, thousands of molecules are doing this all over your arm, that's why you get the chills, especially on a breezy day. Why? Because on a breezy day, you are increasing air currents over the surface of the liquid, and you're making evaporation happen faster. So evaporation can happen faster by doing 3 things. You can increase the temperature, and then evaporation will happen faster. You can increase the surface area of the liquid. I don't know if any of you play tennis, but if there's puddles of water all over the tennis court, people get out a squeegee and they don't mop it up. They just spread it around, and then the Florida sun hits it, and wham bam, shazam, it evaporates much faster. Why? Because you increase the surface area. Or you can get out your fan and you can blow air currents, increase the air currents over the surface of the liquid. So all of these things increase evaporation. So let's review. Evaporation is a form of vaporization. It's when we're going from the liquid to the gas phase. Evaporation has a cooling effect. Why? Because the higher kinetic energy molecules will leave first from the surface, and that lowers the, quote, class average per se, or the average kinetic energy of the molecules left behind. And the 3 ways that we increase evaporation is by increasing temperature, increasing surface area, or increasing air currents. In the next video, we're going to talk about boiling. So this was evaporation, one form of vaporization. Then we're going to talk about boiling in the next video.